The School of Engineering performs world-leading, cutting-edge research. Modern engineering research starts with the fundamental principles of science and engineering and expands to encompass various practical systems. We are proud to now introduce cutting-edge researchers leading the way here at the School of Engineering. Public transportation systems are essential in efficient societies. Professor Koseki examines the safety and security of such systems.
Main academic activity in our laboratory is application of electrical engineering to human mobility, especially rail-guided public transportation. Electric railway has significant advantages in terms of environmental impact and massive transport capability in comparison with other traffic modes. We are studying electric power supply, traction of rolling stocks, and operational planning and control. Many people are living and working in small areas with relatively weak infrastructure in Japan. Therefore, careful and advanced technical research and development are significant. I hope that our study will contribute to sustainable growth of ecological and efficient transports in future.
Under the framework of Innovation Equals Technological Advancement, researchers at our university encourage individuals who will bring about change.
Japan is facing a time to change. Japanese organizations have to expand their activities all over the world. For that, global human resources who can create new values in overseas countries are required. In International Project Lab, research and education are carried out to foster people who take an active part in international society based on knowledge of social infrastructure. Case studies of international projects are carried out with the method of analysis developed in a lab. Based on the result of case studies, methodologies of design and management of international projects are developed. Most of students in our lab enjoy field survey abroad and internship in international organizations such as Asian Development Bank, World Bank, and Inter-American Development Bank. International Project Lab is trying to contribute globalization of Japanese organizations through research and education.
In applied chemistry, Professor Mizuno deals with catalyst engineering, a highly anticipated technique that is seen as a vital component for solving environmental and energy problems.
Mizuno Laboratory has been performing researches and development of catalysts such as automobile catalyst and related sorption and battery materials from molecules to solids. These materials are designed at atomic or molecular levels and synthesized, different from conventional ones. This synthetic methodology is leading to replacement of rare metals with base ones and synthesis of artificial enzymes by mimicking natural one. In addition, we are synthesizing artificial enzymes with all metals in the periodic table. We hope that this will lead to a new paradigm of high performance and environmentally friendly catalyst development and utilization, where government, companies, and universities can participate to create new applications. Thank you.
Skin for robots to convey emotions and a sense of humanity is among the new utility devices being researched by Professor Someya in the field of electronic engineering.
I was so excited when I met organic transistors for the first time. The transistor is mechanically flexible, bendable, and even rollable. The conventional semiconductor devices are all made on rigid substrate, such as silicon. However, if we use organic semiconductors, we can print circuit on plastic films. I was enchanted with its unique features. I considered what bendable transistor can achieve, and I came up with robot e-skin concept. What happens if robot bodies are entirely covered with skin-like sensors? Robots may be able to feel people's warmth and emotions, such as passion, by shaking hands. If pasted on the back of mobile phones, it enables us to input various information just by touching. With flexible sensors using organic transistors, I wish to make machines more human-friendly.
Associate Professor Hirabayashi is currently conducting research on water cycle and resource problems that are occurring due to global warming. She is also one of the young researchers selected as a top associate professor by the School of Engineering.
We are studying the impact of climate change on water resources and water-related disasters. We'd like to know how rainfall glaciers and other hydrological components will change if the ongoing global warming continues in future, and how flood and drought and water resources may change associated with these changes, using numerical simulations such as global warming experiments, satellite remote sensing, and field observation. So our final goal is to provide this information for future sustainable society. The Super Associate Professor Program by School of Engineering gives young scientists an opportunity to have their own laboratories with support of budget, regardless of nationality and gender. I am also the one selected by the program. Here we have several supports such as child care facilities. You can continue your career even after having a baby.
4, 3, 2, 1.
Researchers strive to introduce new systems to better understand our world. Professor Nakasuka is a distinguished researcher internationally recognized as a pioneer in his field.
Nakasuka Laboratory has been conducting research and development of very small artificial satellite called micro-nano picosatellite with less than 50 kilogram weight. Different from conventional satellite of several tons, our satellite is of extremely low cost and can be developed in short time period, which is expected to open a new paradigm of space development and utilization, where not only the government but also the universities, local communities, companies, or even individuals can participate to use the space. Starting with CanSat, two 1 kilogram world's smallest satellite, CubeSat, were developed and launched in 2003 and 2005. Followed by the PRISM, 30-meter ground resolution Earth remote sensing satellite. We are now developing astronomical satellite NanoJasmine to obtain very precise 3D map of more than 200,000 stars in space, as well as 5-meter ground resolution remote sensing satellite Hodoyoshi-1. We intend to build a new social infrastructure with a network of more than 100 satellites, which can continually monitor the Earth's environment, disaster, or human activities. We hope to invite 100 times more people into space development who will create novel ways of space utilization for their own interest and human welfare.